Okay, so this is going to be my first video in a series of videos that will help you in Chemistry 101 as far as being able to master the material. You have 50 minutes in lecture to watch me babble on about all kinds of topics, but then you have to go home and work problems to fully understand what's going on, because without working problems, you're really a spectator. You have to be active in working chemistry problems to really master the material. So what I'm going to do is just have a few problems that I'm going to put on the board, and I'll set them up, and then I'll work through them and I'll talk you through them. And it's really good to actually see the logic and hear the logic. So the first problem is if we wanted to convert 77.3 gallons of a liquid, it doesn't matter what it is, into milliliter. And this type of problem is fundamental in chemistry. We start with something, and it's in a unit of measure, whether it's an English unit of measure like the gallon or a metric unit like milliliter. It doesn't matter. But in science, we typically use what are known as SI, standard units, or metric units, depending on what we're looking at. So to convert gallons to milliliters, you need a conversion factor. And I'll hand out a unit conversion factor table to you in class, and it's in your textbook. So there's no magic in memorizing, or no need to memorize the exact conversion, but you need to know how to use them. Now, what I'm going to show you is a problem-solving technique called dimensional analysis, or factor label. And as we go through factor label problems, you're going to see that it doesn't matter what the units are, as long as you understand how to use dimensional analysis, how to rationally set up a dimensional analysis table. You can work through any problem, whether it's volume, gallons to milliliter, whether it's time, years to seconds, anything. It could be in mixed units, for example, like miles per hour. And so this technique of dimensional analysis is absolutely critical that you get it. And when I first learned it, I actually didn't learn it very well and failed the first exam, but then it clicked, and then I've never looked back. So let's go ahead and solve this problem. Now, to do a dimensional analysis problem, first you figure out what you're given. And this problem is pretty easy. So we're given 77.3 gallons of something. Then you draw a grid, and at the end of the grid, it can be longer or shorter depending on the type of problem. You don't know yet. After the equal sign, you put down the unit of what you're looking for. So milliliter is what we're trying to do. Okay. This grid is simply to represent the math. Anything on top we're going to multiply, anything on the bottom we're going to divide through. So we have gallons, we want units of milliliter. Well, as we pay attention to the units, that tells us when we're done. On this piece of paper, I look at this and I have a conversion of gallons, but it's not to milliliters, it's to liters. So, and again, I'm not memorizing this, I'm literally just pulling off of a paper. 1 gallon, by the way, I'm using the abbreviation. If you want to actually write out the word gallon, that's perfectly fine too. 1 gallon is equivalent to 3.785 liters. Now let's think about what I've just done. I put in a conversion factor from gallons to liters. Mathematically, if we look at the unit, if we treat the unit as we would a variable like x or y in algebra, if I have gallons on top, gallons on bottom, I'm dividing through by gallons. They cancel. That's completely equivalent to if I had x divided by, make it 2x. Right? The x's would cancel, and I'd end up with 1/2. So we're actually doing algebra, but pretending we're not. Well, now gallons have canceled. I'm in the unit of liter. So I need to go from liter to milliliter. I'm not done yet. Well, this is where knowing the metric system, and I will expect you to know everything from kilo down to milli. And again, in the handout, kings have dungeons under dark castle moats. You can use whatever silly phrase you want to memorize it. 1 liter is 1,000 milliliters. Liters cancel. Now I'm in the unit of milliliter. And this is why dimensional analysis is so good, because I know I'm done now. Gallons have canceled, liters have canceled. The unit that's left over is milliliter, but that's what I want. So now at this point, you pick up your calculator and do the math. So 77.3 times 3.785 times 1,000 divided by 1 divided by 1. And this gives me a very large number. So 292,580.5 milliliters. That's what your calculator gives you. But now you have to take a second and think. Significant figures. When you're doing calculations that actually have relevance as far as measurements, you have to use significant figures, and that's a topic we'll talk about in class. In this particular problem, 77.3 is 3 significant figures. So what that means is I need to write this number in terms of 3 significant figures. Well, it's a very large number, so rather than just put a bunch of zeros at the end, this is where using scientific notation. So it's going to be 2.92, and we can actually round this to 2.93 because of the 5/8 that's after it. How many times 10 to the something? And to calculate that, it's 10 to the first, second, third, fourth, fifth. Throwing several concepts at you at the same time of dimensional analysis, significant figures, and scientific notation. But hopefully you'll be doing the homework and these will all kind of merge together in your mind. So our final answer is 2.93 times 10 to the 5th milliliters. And it's always good to just take a second and ask yourself, does that physically make sense? Gallons are large, right? A gallon of milk. Milliliters are small, a cubic centimeter. Basically, you know, like the tip of your pinky, 1 digit of your pinky is about a cubic centimeter. So if we have 77 gallons, we're going to have a very large volume in milliliters. So if this volume came out and it was very small, right there, that would tell you you've done something wrong. Most likely inverted one of your conversion factors. Now, this whole exercise might seem trivial, because I'm sure a lot of you could do this in your head. Well, you know, gallons, liters, so forth. It's very important to learn this systematically. And the reason why we're going to have many problems that require not just 2 conversion factors, but 5 conversion factors, or even more. And those you'll mess up if you try and do them in your head. Also notice I didn't pick up my calculator until I had actually set up the entire problem. There's no need to kind of chipmunk it, you know, to take little bites out of it. Set up the entire problem, then pick up your calculator and do the math. If your setup is correct, the worst that can happen is you make a small mistake typing in the numbers. And I'll do more examples of this throughout the semester.